All right, being a little bit lazy, so I'm literally using the same circuit picture. But if this was a new one or if we hadn't seen it before, eyeballing that, there's no branches. It's one resistor after another. So that's a classic series circuit. Classic series circuit means we get the equivalent resistance by just adding them up. This one has three. If we had a different series circuit that had like 4 or 5 things, we would literally add up those 4 or 5 ohms. For this one, we got 10 plus 15 plus 25. The 10 and the 15 make 25, 25 and another 25. Those three numbers add up to 50. So the equivalent resistance is 50 ohms. As far as the battery is concerned, it's pushing, well, we can see the next part, it's pushing 2 amps of current through a resistance of 50 ohms. To figure out the voltage of the battery, we got to go back to Ohm's law. Voltage is I times R. For this version, we're told the 2 amps, and we just did that good work to figure out the 50. So that means that the voltage of the battery must be 100 volts. It would take a 100-volt battery to push 2 amps of current through 50 ohms of resistance. The power spent by R3. Power is always I times V, but we got to do a little bit of work first to figure out the voltage of R3. This goes to, we haven't used it yet, but this goes to that voltage rule. The battery, Kirchhoff's voltage rule. The battery puts in 100 volts. R3 is going to take out some of those volts. R2 takes out some of those volts, and R1 takes out some of those volts. Altogether, R1, R2, and R3, they team up and they take out the 100 volts. But to figure out the power spent by R3, I need to know how many of those 100 volts, how many of those 100 R3 actually is responsible for. To figure that out, we just backtrack to Ohm's law, V equals I times R. Because this is a series circuit, the 2 amps that was given in the last part goes through all the resistors. So 2 amps goes through R3, and in the question we were told that R3 was 25 ohms. So 2 times 25 is 50. So from Ohm's law, I know that of the 100 volts, 50 of them are taken out by R3. The other 50 are R1 and R2 team up to take those out. I'm just focusing on R3. Now I can finish the question. Power equals current times volts. The current was given as 2. In series, the current is the same everywhere, so it's still that 2 number. And we just did the good math to figure out that the voltage in R3 is 50. So now I can finish it off and say that the power in 3 is the 2 amps multiplied by 50 volts, which is 100 in the metric unit of watts.